All right, Algebra 1, Chapter 6, Section 1. We're going to be graphing systems today. A system is just more than one equation. Think of your car as a system, your classes as a system. You have a little bitty part that makes the whole work. For example, your car doesn't just run on an engine. If you have an engine in a car, but you have no tires, and you have no gas tank, and you have no transmission, then it's not going to run. Everything needs to go together. So let's look at a couple of equations. Let's start with y equals 3x plus 10. I'm going to go ahead and get to some graph paper. Let me get a new page. Graph paper. All right, so we're going to start with, again, y equals negative 3x plus 10. And we're also going to graph the second one, which is y equals x minus 2. Okay, no shading on this one. These are equal, so they'll be solid lines. So let's identify our slope and y-intercept on both of them, and then let's graph them. Okay, first one has a slope of negative 3 over 1 and a y-intercept of 10. So I've got a 10 on my graph, so let's go to 10 as the y-intercept. And my slope tells me to go down 3 and to the right 1. Down 3 to the right 1. So I'm going to graph this line. Look just like that. Okay, so I'm partway there. Then I go to the second one, and I have a slope of 1 and a y-intercept of negative 2. So I go to negative 2. My slope tells me to go up 1 and to the right 1. Up 1 to the right 1. I'm going to keep going because guess what just happened? I have just found my intersection point. The point where these two lines cross, which is, I'm going to highlight that, is right here. Okay, there's the point they crossed. So what you want to do is you want to identify that coordinate. That coordinate is, that coordinate is 3, 1. Okay, that is your solution. If you substituted 3, 1 back into both of those equations, then it would solve them. Now, some of you are saying, what does that mean? Well, let's take a look at it. I'm going to erase the slope-intercept. You need to leave yours in your notebook. And I'm going to substitute in 3, 1. So x is my 3, y is my 1. So everywhere I see a y, I'm going to put a 1. Everywhere I see an x, I'm going to put a 3. That tells me 1 is equal to negative 9 plus 10. 1 equals 1. That is true. I'm going to go to my second equation and do the same thing. Put in a 1. Substitute in the 3. 1 equals 1. That is also true. What that means is that is the only point I can put in those two equations that makes it true both times. Now, some of you might say that, well, what if the lines never cross? So let's look at an example of that. If I have these two. If I did slope and y-intercept on both of these, you're going to see something that is very specific. So the slope of my top one is 2 over 1. My y-intercept is -6. The slope of my bottom one is 2 over 1 with a y-intercept of 4. So you will notice that the slopes are exactly the same. So a green light should pop into your brain. Okay, Mr. Renault taught us about lines that have the same slope. Those are parallel. So of course, when I graph this thing, and then I graph the second one, these lines are parallel, which means they will never intersect. So if you get parallel lines, then you will have no solution. So you could have one solution, you could have no solution, and you might even, let's take it one step further, you might get infinite solutions. Here's what an infinite solution would look like. Okay, hang on just a second. Let me make sure I get this right. Okay, that should work out. The first one, we're going to have a slope of -2. We're going to have a y-intercept of 4. Now we have a problem in the second one because it's not in y equals mx plus b form, so I want it to be. I notice that the y is is over there on the right hand side, so I'm going to switch this around to y minus 4 equals -2x. Again, just because I want the y over there. I want the y by itself, so I'm going to add 4 to both sides. Notice on the right hand side, those are not like terms. So that's just -2x plus 4. Some of you are seeing a green light in your brain right now. Y equals -2x plus 4. It's the exact same equation. So if I were to graph it twice, which I'm not going to ask you to do because you're probably already thinking, well, I know what's going to happen. It's just going to be over itself. And that is true. You don't have to graph it twice. You just need to recognize that it's the exact same equation. So if I graphed another line on top of it, it means it would touch that line as far as the line can stretch. So that's infinite. So this would be infinite solutions. So just to recap, you could have one solution if they intersect each other one time. You could have no solution if they are parallel. And you could have infinite solutions if it's the exact same line. Okay? So this is chapter 6, section 1. And we got about 10 minutes worth. So that is it.